Welcome to This Explainer. For decades, traditional computer software has essentially been a rigid rule follower. Think of traditional code kind of like a train stuck on a track. It was written by hand, given very specific if-then instructions, and completely incapable of doing anything outside of that predetermined path. If a weird edge case popped up, well, a human programmer had to step in and manually lay down new track. But today, we're right in the middle of a massive paradigm shift. We're looking at dynamic thinking technology that adapts, recognizes patterns, and creatively shifts pathways without needing a human to hardcode every single rule. Okay, let's dive into this. To make sense of all this, we're going to take a highly structured journey today. Think of it kind of like opening a set of nesting dolls. First, we'll cover the foundations of AI. Then, we'll peel back the layers to see how AI actually thinks. From there, we'll explore the generative shift, look at AI in the real world, and finally, we'll ground ourselves with the ethical challenges and risks. Section 1. The foundations of AI. Where did it start? So when we say artificial intelligence, what we're really talking about is the overarching concept of software designed to simulate tasks that typically require human reasoning. Problem solving, understanding language, identifying patterns, that's the core objective. And we can trace this timeline all the way back to 1950, when Alan Turing posed a pretty shocking question for the post-war era. Can machines actually think like humans? Just 6 years later, at the Dartmouth Conference, the formal term artificial intelligence was officially coined. Fast forward to 1997, and IBM's Deep Blue defeated a human chess champion. Monumental, for sure, but it was still mostly achieved through brute force math. The real explosion? That started around 2012. This was the dawn of the deep learning era, which was actually driven by an amazing accident of tech. It turns out, graphics cards, or GPUs, originally built to render high-end video games, were the absolute perfect engines for processing massive amounts of data at intense speeds, triggering the neural network explosion we see today. Moving on to Section 2, how AI actually thinks. Let's decode the layers. We're going to zoom in now and peel back the technical layers to decode all that jargon you hear every day. Notice the overarching conceptual onion structure here. This perfectly illustrates that nesting dolls metaphor I mentioned earlier. Artificial intelligence is the massive outer layer, the broad umbrella. But inside that shell sits machine learning, and inside that, neural networks, and deeper still, deep learning and generative AI. Grasping how each specific text sits inside a larger, broader category is literally the key to demystifying the whole field. Plus, it'll save you a lot of confusion at dinner parties. Let's unpack that first inner layer, machine learning. This was a fundamental shift in computer science. Instead of a human manually typing out every rule, like trying to teach a computer exactly how a knight moves in chess, machine learning focuses on models that adapt purely from vast amounts of data. You literally just show the system a million winning chess games and say, figure it out. You feed it data and it learns the underlying patterns entirely on its own. Going one layer deeper, we hit artificial neural networks. This is where systems actually begin to actively mimic biological brains at a structural level. These architectures pass digital currents through cascading weight valves. Actually, scratch that. Instead of rigid mechanical valves, picture billions of microscopic digital dimmer switches. These switches turn up or turn down based on how important a piece of incoming information is, which perfectly mimics how biological synapses in your own brain fire and form connections. So what happens when you scale those neural networks up massively? That's deep learning. We are talking about models operating with over 100 billion parameters. At this massive computational scale, deep learning lets programs process high-dimensional, unstructured information. Now, what does unstructured mean here? Well, unlike neat, clean rows of numbers on an Excel spreadsheet, unstructured info is the messy stuff of the real world. Raw video pixels, chaotic audio waves, and the incredible nuance of human language. It's exactly why a computer can suddenly recognize human sarcasm, compose a beautiful original piece of music, or perform complex medical imaging assessments. All right, Section 3, the generative shift, synthesizing frontiers. Now that we know how the underlying brain works, let's explore the absolute cutting-edge frontier. To truly appreciate this shift, we have to look at the contrast between analysis and synthesis. For years, we had discriminative AI. This is pure analysis. It classifies and predicts from historical data, like recognizing that a picture contains a cat, or trying to predict tomorrow's stock market price. But generative AI, that's all about synthesis. It utilizes advanced machine learning to build completely original content that follows the mathematical patterns of reality but has never actually existed before. It doesn't just recognize a cat, it mathematically dreams up an entirely new, highly cinematic image of a cat walking on the moon. It's a completely wild, creative leap. I know it can feel like absolute magic when you use it, but let's demystify it by looking at the three-phase pipeline. First up is ingestion. These models ingest billions of tokens, which are essentially tiny fragments of words, pixels, or code, to build a massive world knowledge base. Second is pattern mapping. The neural networks map out the statistical probabilities of exactly how those words and pixels relate to one another in context. And third is prediction. You give it a prompt, and the system simply predicts the most likely next sequence, assembling a cohesive output. It's basically a hyper-advanced version of the autocomplete on your smartphone, just operating at an astronomical scale. Now, the secret sauce making this prediction so incredibly coherent is something called self-attention mechanisms inside modern transformer architectures. This allows the model to constantly weigh the importance of different words in a sentence, regardless of how far apart they are. So if you have a paragraph that mentions a bank and much later mentions a river, self-attention is what ensures the AI remembers we're talking about a body of water, not a financial institution. It ensures consistent narrative logic, keeping the AI from losing the plot over long outputs. But here's the catch. Because AI relies entirely on statistical probabilities, it desperately needs direction. AI is a remarkably powerful, high-speed engine, but prompt engineering is the steering wheel. Think about it. A hyper-fast sports car without steering goes nowhere useful. Vague inputs will absolutely lead to exceptionally generic outputs. By providing deep context, specific personas, and highly structured constraints, you direct the model to its most accurate data pockets. Mastering this input is an absolute must for extracting professional-grade results. Section 4. AI in the real world. Everyday applications. Let's zoom back out from the tech architecture and observe how these systems are actively deployed. We've got 4 primary domains of generative AI here. In text, it's instantly generating legal briefs and summaries, vastly accelerating workflows. In code, it's writing foundational scripts and debugging, which completely slashes software development time. In image and video, it's rapidly generating storyboards and 3D designs for prototyping. And in audio, AI is doing narration and voice cloning, which is fascinating because it allows a video to be instantly translated into 5 different languages, all while maintaining the exact original tone of the speaker's real voice. Crazy, right? And you're interacting with these domains every single day, probably without even realizing it. Natural language processing drives the conversational abilities of your voice-activated personal assistants. Machine learning runs the recommendation feeds that instantly suggest your customized entertainment. Real-time neural networks provide invisible fraud protection by flagging weird transactions on your credit card the millisecond they happen. And computer vision is the underlying force translating visual pixels into semantic items like stop sign or pedestrian for autonomous driving. But the next frontier, the absolute cutting edge of where this is all going right now, is native multimodality. Let me clarify what native means here. It means these aren't 3 separate software programs stitched together with digital duct tape. It means we're moving toward unified cognitive architectures, where a single unified AI brain can see a live video feed, hear the surrounding audio, and read the text comments all at the exact same time, seamlessly processing them together to understand its environment. Section 5. Ethical challenges and risks. Managing AI risks. Now, with this massive leap in capability comes some profound responsibility. The probabilistic nature of AI creates some distinct, sobering challenges that we need to look at factually. First, fact verification. Models can hallucinate. Because an AI simply predicts what should come next linguistically, it can confidently present entirely false information as concrete fact, kind of like a very confident but slightly confused intern. Second, bias. Neural systems train on historic human records, meaning AI can inadvertently mirror and amplify systemic algorithmic bias. Third, copyright and privacy. The massive ingestion of scraped web data raises incredibly complex intellectual property and consent questions that courts are battling out as we speak. And finally, economic job shifts. As AI aggressively automates rote tasks, it's forcing widespread upskilling and is actively shifting the global labor market. Okay, we've covered some truly incredible ground today. Let's do a rapid-fire, punchy recap of the absolute core takeaways from this masterclass. Number 1, AI doesn't literally think, it predicts. You have to understand the probabilistic nature of these systems. Number 2, data is the fuel. The training sets determine a model's bias, its scope, and its overall capability. And number 3, prompts are the steering wheel. Your mastery of the input completely defines the quality of your output. Ultimately, the goal here isn't to be intimidated by the technology, but to actively leverage it. As the quote notes, artificial intelligence will not replace humans, but humans using AI will replace those who do not. It's all about establishing that human-AI synergy. Which leaves us with a lingering thought to carry with you. We've seen how the engine is built, we know the data that fuels it, and we know that we hold the steering wheel. The real question is, how will you adapt and steer this technology in your own life? Thank you so much for joining me for this explainer. Keep learning out there, and I'll see you next time.